Okay, now I'd like to work one that has a less than or a greater than. Okay, and I might work two. I might work a less than and a greater than. So I will start with number 13. Okay, I'm going to look at this one, and you still follow the same rules. You still ask, is it isolated? Okay, is it isolated? And then I'm going to also skip to rule 3. I'm going to write my two equations, but there is an exception when I write my two equations, and it is a less than or a greater than. Here's how it works. Whatever's under here, okay, we're saying that we need to be within 6 on a number line. Whatever's under there needs to be 6 away from 0. Okay, so I need it to be equal to 6 or equal to negative 6. Okay, the first one, I'm not going to change that sign. But when you have these, the second one, you reverse the sign. Let me highlight that. Okay, so when you have an inequality, absolute value inequality, the first one gets written just like this. That's perfect. The second one, you got to reverse the sign. I got new pens. I need to reverse this sign. Notice how this sign got reversed. Sorry, it's really the thing I like about this highlighter. Ooh, magic. It's erasable. It's a little too dark though. So let me just stick. You'll notice that this one got reversed. Okay, and that's also the opposite of that. So it's like the opposite and the opposite. One of them you write just like you see it, and one you reverse everything. Well, what's under my handy dandy math tool? Well, it's k minus 9. K minus 9. You know how to solve these. The solving part is not hard. The hardest part will be the graphing. So please watch closely. Okay? All right. I'm going to go ahead and solve both these. It says add 9, add 9. You still have to follow the rule. If you happen to multiply both sides by a negative, you'd have to flip your signs, but I don't here. I just added 9. I'm not multiplying or dividing. 9 plus 6, same sign you add. So k is less than or equal to 15. Okay, solid circle. Normally I would shade everything and keep going until I hit negative infinity. Okay, but I know something, and I'm going to fill in step 2 here in just a second. Okay, I'm going to solve this other one. I'm going to add 9 to both sides, and I get k is greater than or equal to a positive 9 and negative 6. Different signs subtract. So k is greater than or equal to 3. I knew eventually I was going to have another boundary. I knew this was going to be a barbell, an and graph. And the way I knew it is because at the beginning of an absolute value, when it's an inequality, step 2 is I write this go LA. You don't have to like LA at all. If you want to call it GOLA, great. But if it's a greater than or equal to, it's going to be an OR graph. Or, it's going to look like the rowboat. Okay? This was a less than. My original problem started with a less than. If you're not sure which is which, remember to hold up your hand. Okay? That makes the L. This is a less than. So when I'm doing the go LA and I see it's a less than L, I know it's going to be an and graph. And graph sandwiched in between. Okay, and graph. So an and graph is going to look something like this. It could have barbells on it. I mean, solid circles or open circles. This was solid because it had the underline. So I knew it was going to be a barbell in between. And then I'll show you an OR graph. A greater than is an OR graph. Okay, so you have to graph it on the same number line. That one's an and graph. And let me show you an OR. And I'll also show you. So the interval notation actually is quite simple. I'm going to do the interval notation, though, from the graph. I'm going to start with 3, and I get to go up to 15. I get to include both values because they both had the underline. Okay, so this would be our final answer for interval notation. I would have 2 answers, though, as I was solving. 1 graph, 1 interval notation. OR graphs, and this one's going to be an OR. Okay, so step 1, isolate. Well, all of them are isolated today. So I'm going to say isolate your absolute value. So I put my bars up. Second step, go LA, go LA. Maybe you like the Lakers, maybe you don't. Okay, my original problem, that is a greater than. Okay, so I'm expecting an OR graph. I also know sorry. I thought it was yesterday we had fire alarms. Today we've got alerts on my phone. This is going to be an OR graph. Or. Remember the sea lion. Or. His little flippers are going outwards. And they're together or outwards. I also know these are open circles because that's not underlined. So my end graph is going to look like this. I just don't know what these numbers are. Step 3 is write your two equations. Okay, so the first one I write here. I don't change anything underneath this, if I want to cover up my absolute value, you write just what you see without the absolute values there. 7 plus b greater than 6. I didn't change a thing except get rid of the absolute value. When you write two equations, your absolute value is no longer there. We're going to solve now. The second one, you write exactly what you see inside the absolute value. Then you flip everything else. You flip that to a less than, and the 6 becomes a negative 6. I solve both of these. I go ahead and subtract 7, and I get b is greater than negative 1, or subtract 7, b is less than negative 13. Okay, now the way I write mine, my littler number when I'm solving ends up being on the right. So some of you, and that, I think it was Thomas, you wrote like 4,0 in an interval notation today. Just make sure you know which number is smaller. This is negative 13. This is where negative 1 would be. And you'd have 0 up here, and then 1, 2, 3, 1, 2, all that good stuff. If I'm just graphing b is greater than 1, it's an open circle going to the right. Okay, and it's what I expected. Since it was a greater than graph, I'm expecting or. B is less than negative 13 would be going this way. Okay, so there's the OR graph I was expecting. I do ask you then to write it interval notation. Well, if you want to write just this side interval notation, okay, you guys know I would eventually end up at negative infinity, and I'm going up to negative 13. I don't get to include my negative 13. This side, I start at negative 1 and I go up to positive infinity. Well, I need to somehow let you know that both of these could be true. There's a way to write OR and a way to write AND. Or, and the only way I remember, it's either a smiley face, an upside down U, or it's like an A but without crossed. And the way I remember which symbol to use in OR is usually the U. This is an AND. I know that I can turn that into an A. That's the only way I know that's an AND. And to be honest, most times you're going to use an OR. This will have a U in between if you were doing interval notation. This would be the interval notation for this. You're describing two intervals. This interval or this interval. Okay? So an OR is always the upside, is a U. It's a union. I just remember that an AND, I could turn this into an A. Like if this were an AND, I was looking to describe two things, this and that. Okay, but for the most part, you don't have to use AND very often. So I'd rather you, in fact, if you're going to mess up, I'd rather you put a U there than anything.